13 years after announcing the 737 MAX 7, Boeing still hasn't delivered a single one. Over 1,600 jets are sitting undelivered, customers are losing patience, and yet another corporate shortcut has just exploded into a crisis. Regulators are refusing new exemptions, and financial losses are snowballing. So how did the world's most famous jet maker stall out at the finish line again? The answer uncovers more than just technical delays. 5 years after the 737 MAX returned to passenger service, two of its newest variants, the MAX 7 and the MAX 10, remain grounded, trapped in a holding pattern with no clear date for delivery. Airlines that placed their first MAX 7 orders back in 2011 are still waiting for a single aircraft to enter their fleets. The MAX 10, pitched as the answer to Airbus's growing dominance in the single-aisle market, has fared no better. Both models have accumulated more than 1,600 undelivered airframes, gathering dust in factories and storage lots, while airline schedules and business plans are repeatedly rewritten to compensate for their absence. This is not a story of a brand new airplane struggling through the usual teething pains. The MAX 7 and the MAX 10 are variants of an aircraft first certified in the late 1960s, a platform that predates the moon landing. Yet despite that legacy, the latest models have become symbols of unfinished business and mounting frustration. The delays have now stretched past a decade, making the MAX 7 the longest-running, unfinished commercial program in Boeing's history. For context, the original 737 took less time to go from drawing board to first flight than these variants have spent awaiting approval. The reasons for this unprecedented delay run deeper than technical glitches or supply chain headaches. Boeing has repeatedly sought regulatory exemptions, requests to sidestep new safety requirements or defer permanent fixes, instead of tackling core engineering problems head-on. These requests once sailed through the FAA, thanks to a regulatory system built on decades of trust and mutual convenience, but that trust has now evaporated, leaving Boeing's two latest jets stuck in regulatory limbo. Customers like Southwest and United, who built their future fleet plans around these aircraft, find themselves renegotiating contracts, seeking compensation, or turning to competitors. Meanwhile, each quarter of delay adds hundreds of millions of dollars in costs, both for Boeing and for the airlines waiting to put these jets to work. The continued absence of the MAX 7 and the MAX 10 from the skies is more than a technical footnote. It is a public sign that Boeing, once the gold standard of commercial aviation, is struggling to deliver even incremental changes to a half-century-old design. The crisis is no longer about getting grounded planes back in the air. It is about whether Boeing can finish what it started, and what it means when the world's most experienced jet manufacturer cannot. The MAX 7's journey from announcement to delivery has stretched into a 13-year saga that few in the industry could have imagined. Boeing launched the MAX 7 program in 2011, promising airlines a next-generation jet that would modernize fleets and hold down operating costs. By March 2018, the first MAX 7 took to the skies for its maiden flight, and Boeing set an ambitious target: entry into service by early 2019. That timeline has since collapsed under the weight of technical setbacks and regulatory changes, leaving more than 1,600 aircraft across both the MAX 7 and MAX 10 undelivered and idle. For airlines, the impact is measured in more than just missed schedules. Southwest, the largest MAX 7 customer, has spent years reshaping its route network, deferring growth plans, and negotiating compensation for jets that remain out of reach. United, which bet heavily on the MAX 10 to compete with Airbus A321neo, has voiced public frustration and begun shifting future orders toward rival manufacturers. Each undelivered jet ties up capital, disrupts hiring and training cycles, and forces airlines to extend the lives of older, less efficient planes, driving up maintenance costs and undercutting environmental goals. The financial burden on Boeing is staggering. The company has reported over $20 billion in cumulative charges linked to the MAX program, a figure that continues to climb as delays drag on. In the second quarter of 2024 alone, Boeing posted a net loss of $612 million, driven in large part by production slowdowns and penalties owed to customers. Industry analysts estimate that for every year a MAX 7 or MAX 10 remains uncertified, Boeing faces hundreds of millions in lost revenue and cash outflows. Compensation to airlines, ranging from cash settlements to discounted future deliveries, has become a recurring line item in quarterly reports. Backlog numbers tell their own story. With more than 1,600 undelivered MAX 7 and MAX 10 airframes on order, Boeing's factories and storage facilities are filled with jets that cannot be flown, creating a logistical and financial headache. Each month of delay adds pressure, not just from airline customers, but from shareholders and suppliers whose fortunes are tied to Boeing's ability to deliver. The longer the certification limbo drags on, the more urgent the search for shortcuts and exemptions becomes, a pattern that will soon come under closer scrutiny. In 2020, Congress passed a law requiring all new commercial aircraft to feature a modern alerting system known as EICAS, the Engine Indicating and Crew Alerting System. EICAS is designed to centralize and prioritize cockpit warnings, helping pilots quickly identify and respond to problems. For most new jets, this system is standard, but the Boeing 737 family has always relied on a patchwork of warning lights, switches, and audible alarms, technology first certified in the 1960s. When the MAX 7 and MAX 10 were deep in development, this new EICAS mandate threatened to upend Boeing's plans. Retrofitting the 737 cockpit would mean redesigning core systems, rewriting training manuals, and forcing thousands of pilots to learn a new alerting logic, an expensive multi-year process that would break the promise of a seamless transition between old and new jets. Boeing, with strong backing from its largest airline customers, argued that forcing EICAS onto the MAX 7 and MAX 10 would do more harm than good. Airlines like Southwest and United pressed that pilot commonality. The ability to move crews between different 737 models without costly retraining was essential to their business. Boeing's pitch to regulators was clear. Let us keep the old system for these two variants, and we'll avoid grounding fleets, disrupting schedules, and inflating costs. The FAA, under pressure from both industry and lawmakers, agreed to a waiver in late 2022. The MAX 7 and MAX 10 would be allowed to enter service with the same warning system their predecessors used, sidestepping the new EICAS rule. This decision wasn't just about technology. It was a calculation, balancing the cost of modernization against the risk of sticking with a decades-old design. The EICAS waiver became the first domino, setting a precedent for Boeing to seek further exemptions as new technical hurdles appeared. Rather than invest in a full redesign, the company doubled down on the strategy of regulatory negotiation, shaping the path that would define the troubled journey towards certification for the MAX 7 and MAX 10. The 737 MAX's engine anti-ice system was designed to protect against a well-known threat: ice forming on the engine inlet in cold, moist air. To do this, the system channels hot bleed air from the engine itself into the rim of the cowl, melting any ice before it can break away and damage the fan blades. For decades, this approach worked without incident, but the latest MAX variants introduced a subtle, hidden risk, one that only became apparent as engineers studied how composite materials behave differently from the aluminum used in older 737s. In the MAX, the engine inlet is built from carbon fiber composite. This material is lighter and more efficient, but it has a lower tolerance for heat. Under specific conditions, at altitudes between 14,000 and 28,000 feet, with outside air colder than -10 degrees Celsius and the anti-ice system running for hours rather than minutes, the composite can begin to overheat. If the system stays on after leaving icing conditions, the heat delivered by the bleed air can slowly erode the bonds within the composite layers, risking delamination or structural weakening over time. Boeing's internal tests and computational fluid dynamics models pinpointed these thermal hotspots. The FAA certification matrix required Boeing to prove the inlet could handle extended anti-ice operation under worst-case conditions. While millions of MAX 8 and MAX 9 flight hours have passed without a single incident linked to this flaw, the risk, though theoretical, could not be ignored for new certifications. Regulators insisted that a known design weakness, even if never triggered in service, must be engineered out of future aircraft. This is why Boeing sought a time-limited exception, proposing that airlines use strict operating procedures to avoid the dangerous combination of altitude, temperature, and anti-ice usage. But the FAA, wary of relying on procedural workarounds, demanded a permanent fix. The anti-ice flaw became a line in the sand. No more exemptions for problems that could be solved by engineering. For Boeing's teams, the challenge was now clear. Redesign the inlet to survive the harshest conditions, or keep the MAX 7 and MAX 10 grounded. On the morning of January 5, 2024, Dominic Gates published a detailed report in the Seattle Times, laying out Boeing's repeated reliance on regulatory exemptions to keep the 737 MAX program on track. The article described how Boeing was pressing the FAA for yet another time-limited exception, this time to certify new models with an unresolved engine anti-ice flaw. Gates's reporting landed as tension between the manufacturer and its regulator was reaching a breaking point. 6 hours later, Alaska Airlines Flight 1282 took off from Portland. Minutes into the climb, a mid-cabin door plug blew out at 16,000 feet, leaving a gaping hole in the side of a nearly new 737 MAX 9. The crew managed to land safely, but photos of the missing panel and passenger oxygen masks spread worldwide by nightfall. Public confidence, already fragile, collapsed in real time. Overnight, Alaska and United began urgent fleet inspections, and the FAA crisis team convened emergency calls with Boeing and airline leaders. Within days, the FAA issued a public statement. It would not grant Boeing's request for a time-limited exception on the anti-ice flaw. The agency's language was blunt. Boeing's proposed workarounds did not sufficiently assure safety. The decision, announced on January 10, 2024, was the first time the FAA had flatly refused a time-limited exception for a major Boeing program. While the engine inlet issue and the door plug blowout were technically unrelated, the sequence of events left no room for negotiation or delay. Under the glare of congressional scrutiny and public outrage, the regulator drew a hard line. No more exceptions, no more shortcuts. For Boeing, the denial meant the path forward would require a permanent engineering fix, not another procedural patch. The old playbook, built on decades of trust and routine waivers, was suddenly obsolete. The Alaska 1282 incident made the cost of compromise unthinkable, and the regulators' patience had finally run out. Boeing's engineering teams moved quickly to address the engine anti-ice flaw, drafting a redesign that altered the way hot bleed air flowed through the inlet. Initial computer simulations and wind tunnel models looked promising, showing lower temperatures across the composite structure. But as the new design entered physical testing in early 2024, a different problem surfaced. Engineers began detecting low-pressure compressor blade flutter. a dangerous vibration inside the engine that can lead to catastrophic failure if left unchecked. The flutter appeared when the modified ductwork changed the air pressure and flow patterns, creating unpredictable oscillations in the fan blades. Even minor instability in this area is a red flag for certification, since it threatens both performance and safety. Computational fluid dynamics models confirmed the risk. The new geometry, while protecting the composite from heat, introduced aerodynamic disturbances that the original design avoided. With the blade flutter risk now documented in both lab and wind tunnel trials, Boeing had to abandon its first redesign. The team's attempt to patch one vulnerability had inadvertently opened the door to another, arguably more severe hazard. Each failed fix triggered new rounds of analysis, pushing the MAX 7 and MAX 10 further from certification. The episode underscored a hard lesson: quick technical solutions, which, especially on legacy platforms, can unleash complex, unintended consequences that only emerge under the microscope of modern safety validation. Inside Boeing, the Organization Designation Authorization, called ODA, was supposed to blend company expertise with regulatory oversight. In practice, that balance collapsed under pressure. Engineers assigned to certify key systems, including the MAX flight control software and warning lights, reported their concerns were sidelined or dismissed. Some faced pressure to approve designs on schedule. Others described being ignored or moved out of their roles after raising safety objections. Congressional investigations later uncovered emails and deposition transcripts describing a culture where production deadlines often outweighed caution, and where ODA members sometimes felt more accountable to Boeing management than to the FAA. After the MAX crashes, the FAA stripped Boeing of its authority to self-certify new aircraft. Every major design change for the MAX 7 and MAX 10 now required direct FAA review, stretching timelines from months into years. The agency, already operating with limited staff and budget, struggled to keep up. Internal audits flagged exhausted engineers and mounting backlogs. In 2024, an FAA branch manager described the workload as unprecedented, with the best engineers burning out under the strain. The result was a bottleneck. Each technical fix and every new test waited in line for regulatory attention. Delays multiplied not just because of engineering challenges, but because the entire system for approving aircraft had lost its footing. The old trust, once built on routine delegation, was gone. Now, every step forward demanded proof, and the process slowed to a crawl. In September 2025, Boeing's 737 MAX 7 took to the skies once again for certification test flights, a milestone that had eluded the program for years. The FAA, after 6 years of direct control, restored limited authority to Boeing to issue airworthiness certificates, but only on an alternating schedule and under the watchful eye of embedded inspectors. This partial return of responsibility was a cautious endorsement, not a blank check. Boeing's engineers pressed forward on the engine anti-ice redesign, knowing that even minor missteps could halt progress all over again. Industry analysts now warn that unless Boeing and the FAA can rebuild trust and streamline the certification process, the next all-new jet could spend up to 15 years in development limbo. The delays facing the MAX 7 and MAX 10 have already doubled or tripled the timelines that once defined commercial aviation. For decades, certifying a new jet took less than a decade from concept to first delivery. Today, that window has widened, not just for Boeing, but for the entire industry. The resumption of test flights and the measured return of certification authority offer a sliver of hope. But the road ahead remains fragile. Every step forward is shadowed by the knowledge that shortcuts and patchwork fixes are no longer tolerated. The lesson is clear. Rebuilding confidence will require time, transparency, and a willingness to confront hard truths. If that does not happen, the 15-year warning hanging over Boeing's next project may become the new normal for American aerospace. Today, Boeing faces a future where shortcuts are no longer tolerated, and trust is earned, not assumed. With certification delays now stretching beyond a decade, every decision echoes across airlines, jobs, and global safety. The cost of avoiding hard fixes has become impossible to ignore. As regulators hold the line, the real test is not engineering. It's whether accountability finally takes flight.